Children, let us continue the chapter Sources of Energy. Now let us discuss about one of the sources of energy, geothermal energy. Now let us discuss about geothermal energy. Then what is geothermal energy? You know that in the interior of earth there are rocks. The rocks which are present in the interior of the earth melts due to high temperature, and that molten material is called magma. That is called magma. Due to high temperature in the interior of the earth, rocks present there melt, and that molten rock is called magma. Due to some geological changes inside the earth, this magma is pushed upward and is trapped at some depth below the surface of the earth. These are called hot spots and serve as the source of geothermal energy. Hot spots are present below the surface of the earth. Due to the geological changes inside the earth, the magma pushed upward and trapped at some depth below the surface of the earth, and these are called hot spot. These hot spots serve as the source of geothermal energy. Normally, the molten rocks which is called magma is present in the deeper region of the earth, but because of some geological changes they are pushed upward and trapped in the certain region below the earth crust, and this region are called hot spot. When underground water comes in contact with the hot spot, steam is generated. Here see, here there is a hot water production well. Here this is a geothermally heated reservoir, which is nothing but the hot spot. Sometime hot water from that region finds outlets at the surface. Such outlets are known as hot springs. Sometimes hot water from that region finds outlets at the surface. Such outlets are known as hot springs. The steam trapped in rocks is routed through a pipe to a turbine and used to generate electricity. See here, hot water production is there, and that is routed through a pipe to a turbine. Here there is a turbine which is in the powerhouse generation station, and the hot water, that is the steam trapped in the rock, is routed through a pipe to a turbine and used to generate electricity. You know that water is trapped into the earth at a number of places. At places where trapped water comes in contact with hot spots, it gets converted into steam. Since this steam remains trapped between rocks, it gets compressed to a very high pressure. On drilling and introducing pipes up to the compressed steam, the trapped steam can be driven out at high speed. Trapped steam can be driven out at high speed. This can be utilized to turn the turbines and also to generate electricity. This can be utilized to turn the turbines and generate electricity. At some places, steam and hot water find their way through large cracks between rocks and serve as natural geysers. The cost of production of electricity by using geothermal energy would not be much, but there are very few commercially viable sites where such energy can be exploited. There are number of power plants based on geothermal energy operational in New Zealand and USA. Geothermal energy is a clean and environment friendly and economical. Geothermal energy is clean, environment friendly and economical. If suitable source is available, it can be harnessed 24 hours throughout the year. In India, there are only limited places where geothermal energy can be exploited. One such place is located in Madhya Pradesh. Children, now you write about the geothermal energy. So you write that due to geological changes, due to geological changes, molten rock, which is called magma, molten rocks, which is called magma, in the deeper hot regions, in the deeper hot regions of the earth crust, of earth's crust, are pushed upward, are pushed upward and trapped in certain regions, and trapped in certain region are called hot spots. Hot spots. When underground water comes in contact with the hot spot, when underground water comes in contact with the hot spot, comes in contact with the hot spot, steam is generated. Steam is generated. This energy is called geothermal energy. Geothermal energy. Now about the nuclear energy. Energy liberated in the nuclear reaction, like nuclear fission, nuclear fusion, nuclear decay, etc., is called nuclear energy. Then there are different types of nuclear reactions. In that reactions, there is a liberation of large amount of energy, and that energy is called nuclear energy. So you write, what is nuclear energy? Energy generated in a process called nuclear fission is called nuclear energy. You can write, or energy generated in a process like nuclear fission, nuclear fusion, radioactivity, etc., is called nuclear energy. So in the nuclear reactions like nuclear fission, nuclear fusion, tremendous amount of energy is released. Tremendous amount of energy is released. This energy is called nuclear energy. For example, let us take the heavier atoms like uranium, plutonium, thorium, etc. When bombarded with low energy neutrons, it can be split up into lighter nuclei. When this is done, tremendous amount of energy is released, and this energy is called nuclear energy. So you take, for example, heavy atoms like, or you write heavy nuclei like, heavy nucleus like, you write, or heavy atoms like uranium, plutonium, plutonium, thorium, etc. are bombarded with low energy neutrons, etc. are bombarded with low energy neutrons. Heavier nuclei splits up into lighter nuclei, and large amount of energy is liberated in this process. They splits up into lighter nuclei or lighter atoms. In this process, large amount of energy is liberated. In this process, large amount of energy is liberated. Or you write, large amount of energy is released. Large amount of energy is released. This energy is called, is nuclear energy. Here, uranium is heavier nuclei, and plutonium is also heavier nuclei, and thorium is also heavier nuclei. Means uranium is heavier atom, plutonium is also heavier atom, and thorium is also heavier atom. When they bombarded with low energy neutrons, they splits up into lighter atoms. So if here uranium breaks up into barium and krypton. And in this process, large amount of energy is released. This energy is called nuclear energy. This energy is called nuclear energy. There are different types of nuclear reactions. As it is already discussed, first one is nuclear fission. Nuclear fission. Second one is nuclear fusion. Nuclear fusion. Third, nuclear decay. Nuclear decay, or it is also called radioactive decay. And next, transmutation. Transmutation. These are different types of nuclear reactions. In nuclear fission, heavier nuclei breaks up into lighter nuclei when that heavier nuclei is bombarded with some low energy particles like neutron. Nuclear fission means here two or more lighter nuclei combines to form heavier nuclei, and both the cases there is a liberation of large amount of energy. In nuclear decay, some unstable nucleus spontaneously emit some radiations and that undergo decay. Transmutation means one nucleus converts into another nucleus by emitting some radiations. Here, mainly in these two reactions, here the nuclear energy is considered here. You know that first of all we have to consider nuclear fission. Nuclear fission means there is the splitting up of heavier nucleus into lighter nuclei. So here let us discuss about nuclear fission. So we write nuclear fission. Nuclear fission. What is nuclear fission? It is a nuclear reaction in which heavier nucleus breaks up into lighter nuclei when it is bombarded by low energy neutrons. So you write nuclear fission is a reaction. Nuclear fission is a reaction in which nucleus of heavy atom bombarded with low energy neutrons and split up into lighter nuclei. Is called nuclear fission. It is written here. Nuclear fission is a reaction in which nucleus of a heavy atom bombarded with low energy neutron and splits up into lighter nuclei with the release of or with the liberation of enormous amount of energy. Enormous amount of energy. energy. In this reaction, some part of the mass is converted into energy. There is a mass difference. In a nuclear fission, there is a mass difference that is written as delta M between the original nucleus and the product nuclei, and that mass is converted into energy E at a rate governed by the equation E is equals to delta mc square. Here c is the velocity of light and delta m is the mass difference. Here the total mass of the original nucleus is more than the total mass of the lighter nuclei, which are the product after the nuclear fission reaction. So this is the mass energy relation, and this equation is first derived by Einstein in 1905, and so this equation is called Einstein mass energy relation. This is Einstein mass energy relation. Mass energy relation. Here the delta M is the difference in mass that is between the original nucleus and the product nuclei, and c is the velocity of light. C is the velocity of light, or that is nothing but the speed of light in vacuum. So you take delta M is mass difference. Delta M is mass difference. C is the speed of light in vacuum. And the unit of energy in nuclear science is electron volt, EV. So you write in nuclear science energy is expressed in units of electron volts. In short, you can say that is EV. And 1 EV equals 1.602 into 10 power minus 19 joules. 10 raised to minus 19 joules. And it is easy to check from the above equation that 1 AMU is equivalent to 931 mega electron volts. So you take 1 AMU equals 931 MeV. 931 MeV. That is 1 atomic mass unit equals 931 mega electron volt. MeV means mega electron volt. So you write nuclear reactor. What is nuclear reactor? Nuclear reactor is a device in which a fission reaction is carried out in controlled manner, and the released energy is used to produce the electricity. So you write nuclear reactor is a device in which fission reaction is carried out Fission reaction is carried out in controlled manner and the energy released and the energy so released is used to produce electricity. Produce electricity. Here the nuclear reaction is carried out in a controlled manner. How the nuclear reaction is controlled? That is by limiting the number of neutrons bombarding the nuclei. The energy so released in the nuclear disintegration is used to heat water, which then turns turbines and generate electricity. Know that enormous amount of energy is released in the nuclear fission reaction, and that energy is used to produce the steam, that is by heating the water, and that steam is used to rotate the turbine, and so the electricity can be generated. Nuclear power reactors in India. The atomic power station in India, that is nothing but nuclear power reactors in India are: first one is Tarapur atomic power stations in Maharashtra, that is of 420 megawatt. First one you write Tarapur atomic power station in Maharashtra. In Maharashtra. That is 420 MW. Second, Rajasthan atomic power station. Rajasthan atomic power station at Rana Pratap Sagar near Kota. At Rana Pratap Sagar near Kota. Near Kota. And third one, Madras atomic power station at Kalpakam. You write at Kalpakam, or you write the name Madras atomic power station Madras atomic power station in Kalpakam. In Kalpakam. That is also of 420 megawatt, and this quota is 440 megawatt. Then let us take one more, that is Narora atomic power station in UP. Then you take Narora atomic power station in UP. in UP, and also Kakrapur. Fifth one you take Kakrapur Atomic Power Station in Gujarat. In Gujarat, that is Kakrapur Atomic Power Station in Gujarat. Next one more in Karnataka, it is Kaiga. You take Kaiga Atomic Power Station, that is in Karnataka. There is a Kaiga is a name of a place in the Karnataka state, and there is a atomic power station. So then what is the fuel used in the nuclear power reactor? The fuel is nothing but a uranium. So uranium 235. Fuel used is uranium 235. You know that there are two isotopes of uranium, uranium 238 and uranium 235, but uranium 238 is not used because uranium 238 is stable. We need unstable nucleus. So we are using uranium 235. Naturally occurring uranium 238 contains a very high percentage of uranium 238 which is stable, and very low percentage of uranium 235 which can fission easily. As such, naturally occurring uranium cannot sustain a fission process. To make it fissionable, a sample of uranium is required which contains at least 2 to 3% of uranium 235. This can be done by removing uranium 238 from the sample material by the process known as ultracentrifugal technique. This is called enrichment of the fissionable material. So here uranium 235 is fissionable as uranium 238 is stable. So we need more quantity of uranium 235 and we have to do the enrichment. We have to do the enrichment of the uranium 235, means increase the percentage of uranium 235. So that can be done by the process known as ultracentrifugal technique. Nuclear energy is having advantages and also disadvantages. What are the advantages of nuclear energy? Nuclear energy can be used to generate electricity and it is used to treat diseases like cancer. Once the fuel is filled, it can be used for a long time. Small amount of fuel produces a large amount of energy, but it is also having disadvantages. It causes serious health hazards due to emission of harmful radiations like alpha, beta and gamma. You know that the nuclei which are obtained after the nuclear fission reaction are unstable, and the disposal of the spent or used fuels is very difficult. The major hazard of nuclear power generation is the storage and disposal of spent or used fuels. And The three types of radiations emitting by the unstable nucleus are alpha, beta and gamma, and they are having some harmful effects. Which are the harmful effects of these radiations? Alpha rays are harmful when the source producing them enters the body. Exposure to beta or gamma rays can damage the skin. Even a small dose of these radiations is very harmful. These can disrupt cell membrane, damage genes and chromosomes, reduce effectiveness of enzymes, thereby causing serious illness like leukemia and cancer. So, they are also used to treat the cancer, and also they themselves also causes the disease cancer. Then you write what are the advantages of nuclear energy. So you write that small amount of fuel produces a large amount of energy. Small amount of fuel produces large amount of energy. And also nuclear energy can be used for the constructive purpose like generating electricity and to cure the diseases like tumor and cancer. And also one more advantage is that the fuel once filled can be used for a long time. The fuel once filled can be used for a long time. Now you write the disadvantages of nuclear energy. First one you write the major hazard of nuclear power generation is the storage and disposal of used fuels. The major hazard of nuclear power generation is the storage and disposal of spent fuels. The radiations emitted by the fuels causes health problem. So you write it causes serious health hazards, serious health hazards due to emission of harmful radiations like alpha, beta, gamma. These are some disadvantages of nuclear energy.